Howdy folks, I'm Brian and I'm going to walk you through this exercise in engineering ethics entitled The Incident. We're referring to, in fact, an incident in which I play the role of a design engineer employed by the Department of Transportation. I designed a traffic signal and it failed after a week of being installed in the all green position. So all the lights in every direction were green and two cars, they both went through on a green light and got in an accident, causing serious injury. Now, if we want to find out who is the responsible party, we would hold what we used to call in the Navy a fact-finding, but what was more informally referred to as the blame game. In this case, the parties that could possibly be responsible are the engineer, that's me, the technician, the one who tested and built the circuit, the supervisor, who supervises both of us, myself and the engineer, and of course the drivers, who should have been paying attention. We absolutely cannot blame the drivers. That wouldn't be fair to them. It wouldn't be realistic. It's reasonable to expect if you're driving a car that if you see a green light that it's safe to go. And if you're driving 45, 50, 55 miles an hour down this road, you're not thinking that another car is driving the same speed coming the opposite direction. If you did get to the intersection and you did see the car coming, you wouldn't be able to stop fast enough to prevent an accident. This was going to happen regardless. The circuit failed, and we know that it failed, and we really knew that it would fail because everything fails eventually, or at least it's very probable that it will. Good engineering practice is that we make something to fail safe. So when it fails, we don't want to see two green lights. We prefer to see two red lights. This would be accomplished by installing a very simple interlock that I'll show a schematic for on the next slide. Both drivers would see a red light, and then they'd be conditioned to stop at the red light, and they probably would sit there for a few minutes and they'd stare at each other and say, well, are you going to go or am I going to go, because both lights are red. Eventually they'll use hand signals, and one of them will go and then the other one will go, and nobody got hurt. So the lights, the red, yellow, and green lights in general are controlled by a state machine. The design of that machine is not really applicable to the discussion we're having, which is just about the interlock. It's a safety feature that's outside the state machine, but inside the lights themselves. So the signal from the control circuitry before getting to the green light bulb and turning it on, it's going to go through an AND gate, and connected to their input of that AND gate is a NOT gate or an inverter coming from the other green light. So if one green light's on, the other one can't be on. In other words, both green lights cannot ever be on at the same time. Now, the very worst thing that could happen would be that none of the lights are on at all. So the people that are driving, they're going to come up to this intersection where there's a traffic light and none of the lights are lit up, and they're going to follow the law, which is to stop and look both ways and make sure it's safe to go. And they're going to treat the intersection as a four-way stop, because that's what they're conditioned to do when all the lights are out. Now, a case could be made that the engineer was responsible for this accident because he designed the whole system, and he didn't design it very well, because when it failed, it had two green lights showing. Now, engineers do make mistakes, and that doesn't mean they can't be held responsible, but it is a fact of life. They make mistakes. Technicians also make mistakes, so I can see how you would form an argument that the technician performed this test. He built the circuit, he performed a test, he should have caught it. But we don't know who wrote the procedure for the test. We don't know whether he tested for the particular malfunction that the system went through. It could have been an unpredictable malfunction. It could have been any number of things. So if I was not the engineer and instead I was the investigator performing this investigation or analysis or fact-finding, I think I would put the blame squarely on the supervisor. Both the engineer and the technician work for him, and he put his signature on the light saying, yes, this light's good to go. This is a perfectly safe light. And no, it's not safe at all. We saw what happened a week later. If I was the investigator internal to the Department of Transportation, and I'm handling this for the CEO or whomever, and they said, look, you got to fire somebody. This is a big deal. My recommendation would be to fire the supervisor.